Hello everyone, this is the North American Math Contest Go Go Go. Today we are going to do videos on the geometric theory. So let's first talk about what geometric theory is. It is defined as the sequence with each successive term multiply the constant not zeros into the previous term. So for example, I'm going to give you an example of it. 3, 6, 12, 24. As you can see, the second term divided by the first term is 2. The third term divided by the second term is 2. The fourth term is divided by the third term is also 2. So, in this sequence, each successive term is multiplied by 2 compared to the previous term. So, this is a geometric sequence. If we define it through listing constant, then it will be first term is a, second term is ar, third term is ar squared, fourth term is ar cubed, and then the nth term is ar to the power of n minus 1. So let's see an example. We are required to find the eighth term of a geometric sequence. In this case, it is going to be 3, 12, 48, 192. So as we can see, 3 comes first. So the first term is going to be 3. A2, on the other hand, equals to 12. So 3r is to 12, so r is equal to 4. So A8, as you can see, A8 is equal to AR to the power of n minus 1 according to this. So A8 is equal to AR to the power of 7. So this means that 3 times 4 to the power of 7, which is equal to 49,152. Now let's look at another harder question. The fourth term of a geometric sequence is 125 and the ninth term is 125 over 32. We are required to find the 13th term. So we know that the ninth term is ar to the power of 8 and the fourth term is ar to the power of 3. So we can divide ninth term by the fourth term because in this case a will be cancelled out and then it will be r. So for example, ar's ninth term is ar to the power of 8 and fourth term is ar to the power of 3. So it's r to the power of 5 is equal to 125 divided by 32 divided by 125 is equal to 1 over 32. So this makes r is equal to 1 over 2. Remember it's plus, by the way. So after that, we are required to find the 13th term. But before that, since we know that the a is cancelled, we still need to find out the value of a. We plug in 1 over 2 into the fourth term. So this means that it is equal to ar to the power of cube is equal to 125. So it's equal to a1 to the power of 2, this. So it is equal to 1 over 8. A is equal to 125. So a is equal to 1000. And then we know that a is 1000. R is 1 over 2. So if we 1000 times 0.5 to the power of 12 is going to be equal to 125 divided by 512. Okay, after we have talked about the geometric sequence, let's talk about the sum of a finite geometric series. So basically to intuit what it is, we can first denote Sn as the sum of the first n terms of the geometric sequence. And we minus it by r, we minus it by Rsn, so it becomes negative ar minus negative ar squared minus negative ar cubed minus something. So we know Sn minus Rsn is equal to a minus a to a arn. So 1 minus r is equal to a times 1 minus r to the power of n. So Sn is equal to a times 1 minus rn divided by 1 minus r. So this would be the correct equation for Sn. Now let's talk about the sum of the infinite theory. The bulk of experiences, formulas only working ARN like where it is finite, but what about if it's infinite? Let's see what we are going to do. So, sum of the infinite theory, sine f is is equal to S_inf is equal to A minus A divided by 1 minus R. However, one case condition that R, the absolute value of R must be less than 1, because if it is equal to 1 or larger to 1, the sum will just be easy, simply infinite. Let's see an example. 2, 4, 6, 8, 16. In this case, we can see that each term has a R equal to 2, because 4 divided by 2 is equal to 2. So this means that if we add them, each term will be constantly increasing, which will definitely reach infinity. Therefore, we must pose this restriction prior to calculating the sum of an infinite sequence. Now let's do some practice problem. So the first practice problem will be find the sum of the geometric sequence 2 plus 6 plus 18 plus 54 plus 1458. So we assume that the A1 is the first term, which in this case is going to be 2. So A is equal to 2. The second term, AR, as a value of AR. So since we know above that A is equal to 2, R must be equal to 6 divided by 2, so R must be equal to 3. So in this case, we know that the general formula is going to be 2 times 3 to the power of n minus 1. And then we put this equal to this to see the value of n. So this means that we can find out how many terms we have, which we find out that it has a term. After finding out a term, we only need to substitute the value. A is equal to 2, R is equal to 3, and n is equal to 8. So this one is A, this one is R, and this one is n, the 8. N is equal to 8. So we know the value is 2186. Let's then talk about another example. So we're required to solve this, where we are given a restriction that 0 is less than x less than 45 degrees. So basically to solve this, we need to we first need to set out S infinite is equal to A divided by 1 minus R. So it is equal to 1 divided by 1 minus 10x is equal to 1. So basically we know that 1 minus 10x is equal to 1. So this means that 10x is equal to 0. 10x can be 0 degree or 180 degree. However, 180 degree is out of bound because it is not in the 0 to 45 range. So we reject the second one. Reject. And we keep the first one. Therefore, through this problem, we can see that the result that we want to obtain is that x is equal to 0 degree, and that is our final answer. Here we come to the end of our geometric sequences, and I hope you have learned a lot. See you next week. Bye bye.